Question number 1. A thin plate of irregular shape is suspended freely by a cord from point A as shown in the figure. Next, the plate is suspended freely from another point B as shown in the figure 2. The center of gravity of the plate is most likely to be found at. In the first figure, they have given the object is suspended by point A. A dash is like this. Then center of gravity should be on this straight line. We know that the suspended point and center of gravity should be in the same straight line. When suspended it by B, again we have to draw vertical line. When considering vertical line of this second figure and first figure, we can draw it in same figure. It should be like this: A dash, like this. And we can consider the intersection point. A dash should be below A. Then we can join A dash from in second figure, and we have to draw vertical line, and we have to find the intersection point of this vertical line and A dash straight line. A dash is the vertical straight line corresponding to the first situation. Then we have to get the intersection point for both situations. Center of gravity should be on the vertical straight line. Then you can draw two straight lines and find the center of gravity. Then answer should be S. Line should be passes. Line should be past point S. Then center of gravity should be S. Answer is 4 for the question number 1. Then question number 2. The diagram given is a cross-section of a toy placed on a horizontal table, which always turns to the upright vertical position when released. Then the center of gravity of the toy is most likely to be. If the toy is always upright, center of gravity should be a point like D, because of center of gravity should be a point near to this edge. When considering equilibrium, it should have a vertical equilibrium and stable equilibrium. For the stable equilibrium, center of gravity should be near the bottom of the object. Then we can consider D and E, but E could not be the center of gravity. E is this point. When considering an object, there are masses in this side. Therefore, center of gravity should be near to the below edge, but it could not be E because of there are masses in this side. Then we can consider D should be the corresponding center of gravity for the second object. For the given object, then we can consider fourth one is the correct answer for question number 2. We have to guess the center of gravity. Then question number 3. A person bends over and touches his toes as shown in the figure. The center of gravity of the person is most likely to be found at. He is in this position, like this. Then we can consider center of gravity should be a point like this. It should be near to the given person, and its center of gravity should be in this area. Then we can get B should be the center of gravity. Then answer is 2 for the question number 3. Then question number 4. The coordinates of center of gravity of a uniform sheet of cardboard shown in figure are x0 and y0. x0, y0. Cardboard is now folded along OP as shown in the figure B. The center of gravity of the xy folded cardboard has coordinates where we can consider in first situation the figure is like this. Center of gravity should be in this straight line, this dotted line, because of masses are symmetric around this line. But if the object is folded, now this mass of this part is moving to the right hand direction and downward direction. When folding, mass of this part is moving, center of gravity of this part is moving to the right hand direction and downward direction. Therefore, y coordinate of center of gravity should be less than y0, and x coordinate of center of gravity also x coordinate of center of gravity should be greater than x0. Center of gravity of the object is moving to the right hand side. Therefore, x value, center of gravity coordinate of this situation should be greater than this one, and center of gravity is moving downward direction. Therefore, y should be less than y0. Then we can get correct answer is fourth one for the question number 4. X should be greater than x0 and y should be less than y0. Then question number 5. When a H-shaped body shown in the figure is hung from point B, it hangs with point D direct below B. When the body is hung from point E, it hangs so that the point C is directly below E. The center of gravity of the body is more likely to be at. Then the object is hung from a point the hung point and center of gravity should be in the same vertical straight line. It is the theory. Then we can consider in first situation they have given H-shaped body is hung from point B. Point B is this one. D is directly below B. D is this one. Then this straight line should be the vertical line when hanging from B. In the second situation, they have given it hangs so that the point C is, when the body is hung from E is the point like this. point C is directly below E. Point C is this one. Then this should be the vertical straight line. Then again the given object by E. Then we have to get the intersection point of this straight line and this straight line as the center of gravity of the object. It is more likely to be S. It is like point S. Then we can consider it should be the center of gravity. Fourth one is the correct answer for question number 5. Then question number 6. The water molecule has a shape shown in the figure. The center of gravity of the molecule is most likely to be found at. We know that when considering a water molecule, the large mass is oxygen. Therefore, this object is symmetric around this dotted line. Therefore, center of gravity should be on this straight line. And large mass is oxygen. Therefore, the center of gravity should be near to the oxygen atom. Then we can get it should be the center of gravity. If these two masses are not in the figure, then center of gravity should be midpoint of this oxygen atom, P. But there are two masses in right hand side, therefore center of gravity should be moved in right hand direction. But large mass is oxygen, therefore it is near to the oxygen. Then it should be the corresponding center of gravity. Answer is 4. Then question number 7. A uniform wire is bent as shown in the figure. The center of gravity of the whole wire is mostly likely to be found at. There are 1, 2, 3, 4, 5 parts in the figure. 1, 2, 3, 4, 5. All parts are with the same mass because of there are same length. This length and this length equal. The center of gravity of the object should be in this straight line, on this straight line, because of the diagram is symmetric around the dotted line. Now, if this mass also on this straight line, center of gravity should be this point. But there is a mass. The mass of this part is displaced in upward direction. Therefore, center of gravity should be moved in upward direction. And if these two masses are, there are two masses in vertical parts, these two parts. Therefore, we can consider the center of gravity of the object should be midpoint of this straight line. There are two masses should be below the midpoint of this straight line because of when considering these two parts, center of gravity should be midpoint. And then we can consider masses of this horizontal length. There is only one length in upward direction, there are two lengths in downward direction. Therefore, center of gravity should be below the midpoint of dotted line. And then we can get answer should be C. Then third one is the correct answer for question number 7. Question number 8. The center of gravity is most likely to be found at, there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 squares in the given diagram. It is like this. 1, 2, 3, 4, like this. We can consider center of gravities of parts of the given figure. When considering these 4 squares, center of gravity should be this place. And when considering these 4 squares, center of gravity should be this point. I will consider center of gravity of these 4 squares first. It should be this point. And then I will consider center of gravity of these 2 squares. It should be this one. If this part and this part, if we are considering this part and this part, center of gravity should be midpoint of this straight line. But due to this weight, the center of gravity of the object should move in this direction. There is a weight in this part, and due to this object, this square, the center of gravity should be moved in this direction. Then we can get, it should be like point B. Point B is this one. Then answer should be 2 for the question number 8. Then question number 9. The frame shown in the figure is made from a uniform wire. The center of gravity of the frame is mostly like to be found at. When considering given frame, if we are considering only this straight line, center of gravity should be point T. It is the midpoint of straight line. Then we can consider these 2 parts. When considering only these 2 parts, center of gravity should be midpoint of these 2 parts. And due to this mass, red colored mass, the center of gravity should be moved in upward direction. And we know that there are 3 parts in this straight line relative to this part. Therefore, the large mass is near to this straight line. Then center of gravity should be near to this straight line. Then we can get point D as the center of gravity. Fourth one is the correct answer for question number 9. Question number 10. A uniform circular plate of radius 2r has a circular hole of radius r cut out from each as shown in the figure. The center of gravity of the plate with the hole is most likely to be found at. If there is a full circle, the center of gravity should be center of the circle. But they have removed a circle like this. Then considering this small circle, its center of gravity should be this point. But when removing this part, center of gravity should be moved in the left-hand direction, and it should be on this part. Therefore, we can get center of gravity should be a point like this. Then we can get D is the answer. Fourth answer is the correct answer for question number 10.